Hi guys, in this episode of Shri series, we're going to be talking about changing the subject of a formula. We're going to give some examples and show ways in which we can manipulate algebraically certain functions using this topic. All right. I found this topic very useful, particularly with maths and science, because in science, specifically in physics or physical science, students get to use formulae and how it's important to manipulate certain parts to help understand. All right. So if we use changing the subject of the formula, it's important to understand what we've been given. All right. So let me just give an example. And if you've been watching my previous videos, we talked about kinetic energy and potential energy. So let's use that as an example. So if you look at potential energy, we know potential energy is mgh. All right. So I'm not going to go into what potential energy is. We're just going to look at the mathematical aspect of what potential energy is. Now, suppose we've got potential energy. We know it's mgh. All right. Suppose we've been given potential energy. We've been given g and h, and we want to find m. All right. So let's put a situation here. Let's say we want to find m. All right. How do we find m? How do we make m the subject of the formula? All right. So if you look at this equation, potential energy becomes the subject of the formula. We want to now make m the subject of the formula. So what do? So one simple way of approaching this question is when we want to make m the subject of the formula, we need to divide both the left-hand side and the right-hand side equally by any variable that will give us m. So if you look at here, we divide by g and h. All right, so we divide by g and h here because whatever you do on your left hand side, so if you remember from my previous videos, whatever you do on your left hand side, you need to do them on your right hand side as well. Okay, so we're dividing by gh on your left hand side and we're also dividing by gh on your right hand side. So if you look carefully, the g cancels out, h cancels out, and therefore m becomes potential energy over G times H. All right. So that's how you make M the subject of the formula. All right. So what you do is you divide by a variable that will give you M literally. So that's G and H that cancels out and you do on the other side of your equation. All right. So that's how we make M the subject of the formula. All right. Let's try again, but this time let's make H the subject of the formula. All right. So rub this out and then we'll make H the subject of the formula. All right. So we know potential energy PE is mgh and we want to say find H. All right, so we want to make H the subject of the formula. All right, so like I said, we divide it by a variable that will give us H. So what we do is we divide by M and G. Divide that by M and G. All right, so the M cancels out, G cancels out. So we get H. Therefore, H equals potential energy over mass times acceleration due to gravity. So we've now made H the subject of the formula. So you can see when you're solving these questions, what we need to do is we need to be familiar with changing the subject of the formula. Some textbooks call it changing the subject of the formula. Other textbooks refer to it as algebraic manipulation. We're manipulating to find another variable. All right, so like in this case, we're finding H, which is potential energy over mg. All right, so that's how we work through manipulations using potential energy. All right, now let's look at kinetic energy and how we can find different variables here. Okay, so I'll write down the kinetic energy formula, and if you've been looking at my videos, I've put some calculations on kinetic energy. Like I said here, I'm not going to explain what kinetic energy is. We're going to look at manipulating kinetic energy. All right, so kinetic energy here is half mv squared. All right, so kinetic energy is half mv squared. Okay, now I want to find m. All right. So I've got my kinetic energy, I've got my velocity, and I now want to find m. How do I make m the subject of the formula? All right. So if you look at this equation, it's slightly more complex, or should I say slightly more tricky than the previous potential energy question, because in your potential energy questions, you just had m, g, and h. Whereas in the kinetic energy, you actually got v squared and you got a fraction, which is 1 over 2. So how do you work across this situation? Okay, so the first thing I would do is I would multiply both my left hand side and my right hand side by 2. So in that way, I can get rid of the half, and that becomes 1. All right, and remember, I've put a bracket here as well as there, because whatever you do on your left hand side, you've got to do it exactly on your right hand side there. So what does that become? That becomes 2 kinetic energy equals mv squared. All right, because 2 divided by 2 becomes 1, and that's why that's mv squared. All right, now this becomes easy because what we need to do is we want to make m the subject of the formula. So all we need to do is divide by v squared. So divide by v squared and divide by v squared, because you know whatever we do on your left hand side, we've got to do it on your right hand side. So the v squared cancels out. So m therefore becomes 2 kinetic energy over v squared. All right, so that's how we solve for m. We've made m the subject of the formula. All right, so what we've done is we've multiplied by 2 so we can get to that fraction to make that into a whole number, which is 1. So that's 2ke equals mv squared, divide by v squared, and we've got m is equal to 2ke over v squared. All right, now let's look at another situation where we now make v the subject of the formula. All right, so I'm just going to rub the blue parts and this time make v the subject of the formula. Just rub that bit there. Yeah, we'll wrap this one here, and we'll wrap this one here. All right, so we need to say find v. All right, so what do I need to do? I'll multiply this by 2 again, so we can get rid of the fraction. So that's 2 kinetic energy equals mv squared. All right, now we need to divide by m, so we can get v squared. All right, so the m cancels out, so v squared equals 2 kinetic energy over m. Now the questions asked us to find v, all right, not v squared. All right, so what we need to do is we use the opposite of a square, which is a square root. Okay, so I'm just going to move this here. So in order for me to get v now becomes 2 kinetic energy divided by your mass, and you find the square root. As you know from basic maths, the opposite of a square is a square root. So in other words, for example, 5 squared is 5 times 5, which is 25. And if you want to get the square root of 25, that's the sign. All right, so you can see the opposite of a square is a square root. So that's how we find and solve for v in this equation. So what we've done is we've multiplied by 2, divided it by m to get v squared, and then we find the square root because the questions asked us to find v. All right, so that's how you can manipulate algebraically or change the subject of a formula, because you will notice that in physics you're going to be having some equations. Some of them are simple equations, some of them are complex equations, and you need to find one of the variables. And unless you understand the topic of algebraic manipulations or changing the subject of the formula, this bit will become really hard. All right, thanks for watching, guys. Bye now.